Hello everyone, it's my great honor to present our work in MIT AB conference. The topic that I'm going to present is Towards Carbon Neutrality, the pricing of back sharing, considering carbon price. Okay, before the presentation, please allow me introduce myself briefly. My name is Shang. I'm currently a lecturer in the College of Metropolitan Transportation, Beijing University of Technology, and I'm also appointed as Honorary Senior Research Fellow of Imperial College London. Prior to joining BGUT, I have received the PhD degree from the Center for Transport Studies, Imperial College London. I have already published more than 40 academic articles. My research interests include intelligent transportation system, energy conservation and emission reduction of transport systems, traffic big data, and so on. Okay, let's start with the background of this study. As we all know, with the development of urbanization and industrialization, global warming caused by greenhouse gases has become a main concern of our society, which threatens the existence of human beings. In order to cope with this situation, the Paris Agreement sets the goal to limit long-term global warming to less than 2 degrees Celsius, and preferably below 1.5 degrees Celsius compared to pre-industrial levels. In response to the Paris Agreement, the European Union is committed to achieving carbon neutrality by 2050, based on the European Green Deal. In September 2020, China committed to peak its carbon emissions by 2030 and achieve carbon neutrality by 2060. To date, more than 156 countries have set goals for delivering carbon neutrality. At the same time, transportation sector has been regarded as an important source of greenhouse gas emissions. The transportation industry requires to vigorously promote green traveling modes. Transportation sector can contribute approximately 24% of global carbon emissions. To achieve the carbon neutrality in transportation sector, shared travel modes are encouraged. Hence, bike sharing is regarded as one of the important ways for the general public to participate in achieving carbon neutrality. However, bike sharing does not have significant price advantages compared to vehicles and buses. Well, carbon trading utilizes market mechanisms to mitigate climate change and greenhouse gas emissions. In China, some experts and legislators even propose to set up personal carbon account for traveling to encourage people more frequently adopt green transportation ways. Therefore, in the context of carbon neutrality, it's very important and interesting to explore the pricing mechanism of bike sharing by considering carbon price. Let us move on to the literature analysis. We conduct a literature review from two perspectives, bike sharing and carbon price. Let's see the literature related to bike sharing. We have analyzed more than 1,500 references. As can be seen from the left figure, the most frequent keywords include built environment, sharing economy, sustainability, rebalancing problem, physical activity, infrastructure, and the right figure shows the research trend related to bike sharing. It shows that people tended to focus on safety, risk, policy, routing, and so on in the past, where big data, predictive models, COVID-19, congestion, smart transportation has become the latest keywords. As for carbon price, the left figure shows the carbon emissions, renewable energy optimization, carbon tax, performance, life cycle assessment are most frequent keywords, and the right figure shows the research trend related to carbon price. It shows that carbon sequestration, agriculture, biodiversity, deforestation are more focused at the early time, but currently the studies are more concentrated on the algorithms, life cycle assessment, and carbon emissions. Based on the literature review, we found that the number of research related to back-sharing and the carbon price is considerable, but the pricing of back-sharing based on the carbon price prediction and the estimation of carbon emission reduction potential for back-sharing has not been explored so far. In our study, we propose a method to price the back-sharing by considering carbon price. It's very straightforward. It's directly deducted the potential benefits of carbon emission reduction from the original price of back-sharing. Here, there are two methods to calculate the second term of the equation: potential benefits of carbon emission reduction. The method 1 averages all benefits caused by all back-sharing trips, while the method 2 is calculated based on individual back-sharing trips. P0 is the original price without considering carbon price. Although there are two methods to calculate the second term, that is, potential benefits of carbon emission reduction, but both methods are based on the prediction of carbon price and the estimation of environment benefits of back-sharing. As for the prediction of carbon price, we select the long short-term memory model to predict. LSTM is a type of neural network with ability to memorize long-term and short-term information. As long as training data are input into the model, it does not need to clarify the relationship between inputs and outputs. LSTM is also a variant of recurrent neural network. The reason why we choose LSTM to predict carbon price is that this method is suitable for dealing with time series data. RNN is able to handle the series data as well due to its ability to memorize information and its advantage in learning nonlinear characteristics, so it can be used for natural language processing. However, when RNN processes data, the value of the hidden layer will be stored at each time step and used at the next time without selection, which implies that all information will be stored. While LSTM can selectively store information through its own three gates, namely input gate, output gate, and forget gate. Because of the time limitation, I'm not going into the details. In a word, compared to RNN, LSTM can resolve the long-term dependencies and the vanish gradient problem, which is important to time series data prediction. In this study, we mainly utilize the daily transaction price data for carbon emission and the data side of external impact factors as a training or test set, so as to fit the carbon price in the market. Let's see the second component of the proposed pricing model. Estimation of environment benefits of back-sharing include two steps. The first step is to estimate the trip distance of back-sharing. In the traditional way, the trip distances are calculated based on the straight line between origins and destinations, namely Euclidean distance, which tends to underestimate the realistic distances of trips. Given this, we propose a novel method to calculate the trip distance with limited trip information. This method assumes that all users of back-sharing are very rational and always choose the shortest passes between origins and destinations and their routes. The main idea of the method is to calculate the shortest passes between origins and destinations based on urban backbone road network extracted by OSMNX, which is an open Python package to extract, model, visualize, and analyze road networks from OpenStreetMap. The second step is to estimate the emission reduction. Here, the environment benefits refer to the emission reduction potentially caused by using back-sharing. Back-sharing is assumed to be able to replace the traveling by vehicles if the distances between origins and destinations are reasonable. In other words, if the distance exceeds a threshold, people consider to take taxis or private cars for traveling. We estimate the carbon emission based on this equation, and this table shows the calculation procedures for environmental benefits of all back-sharing trips. We are not going into the details because of time limitation. Now we are going to the case study. In this study, we select Beijing as our research area, and we can see these two networks are road networks for back and vehicles, which are both extracted by OSMNX. Due to the limitations of data source, we only have back-sharing trips from 14th January to 10th March 2020, which covers the dates of important events during the outbreak of COVID-19 pandemic. The dataset here includes trip data of three main dockless back-sharing operators in Beijing: Mobag, Hellobag, and Qingjubag, which accounts for the 95.7% of the average daily orders. To predict the carbon price in Beijing, we set up LSTM model with two layers. The first layer has 256 units, and the second layer has 64 neutron units. Here we select 14 external factors as inputs, such as spot price of crude oil, air quality index, monthly average temperature, which may impact the carbon price, and the monthly average transaction price of Beijing carbon emission rate is used as output. Here, RMSE and MAE are used as the assessment index. Based on the value of RMSE and MAE, it can be observed that prediction results B has a relatively better fitting effect. So in this study, we choose to use the predicted carbon price based on MAE for analysis. As for the results of estimation of environmental benefits of back-sharing in Beijing, as we can see, the distribution of potential environmental benefits and the origins and the destinations are presented, and we just selected 3 days for presentation. Apparently, back-sharing on 10th March achieves much better environmental benefits than those on other 2 days due to the impact of COVID-19 outbreak. On 10th March, back-sharing is estimated to achieve potential carbon emission reduction about 167,000 kilograms. Finally, let us see the results concerning the price of back-sharing considering carbon price. Due to the time limitation, we just select 25th January to present. It shows that the benefits of carbon emission reduction for a single trip combined with the actual carbon price are about 0.01 yuan to 0.54 yuan, where the benefits of carbon emission reduction for a single trip combined with the predicted carbon price are about 0.01 yuan to 0.44 yuan. We also can observe from this figure that the back-sharing with lower price accounts for a very large proportion. When travel price smaller or equal to 1.5 yuan, it's about more than 94%. If the final price smaller than 3 and greater than 1.5, it's about 3.5%. We also find that the pricing method of back-sharing considering the carbon price can lead to a lower price, which can improve the price attractiveness of back-sharing to some extent. According to our method, as the current trend of back-sharing usage, if people wanted to free use back-sharing, the carbon price should reach more than 1,200 yuan per ton at least. Now let us come to the conclusion. Firstly, in the context of carbon neutrality, this study for the first time proposes a pricing method of back-sharing considering carbon price, and it's expected to contribute to the popularization of green travel modes and the realization of carbon neutrality in the transportation sector. Secondly, as the carbon trading market is still at its early stage, According to our proposed method, the majority of back-sharing chips can only achieve less monetary benefits of carbon emission reduction under the background of carbon neutrality. Thirdly, according to the current situation, if people wanted to achieve the free use of back-sharing, that is, the carbon emission reduction benefits and the cost of back-sharing must be equivalent, the carbon trading market must be highly developed, and the carbon price should up more than 1,200 yuan. In addition, two limitations exist. Due to the limited data source, we have to use the back-sharing date in 2020 here, which weakens the perspectiveness of our study. Also, the current LSTM model should be improved to more accurately predict the carbon price. This is my presentation. Many thanks. If you have any questions, please feel free to contact me. Thank you.